Hello, young people. This is Mr. Tolbert's class. This happens to be a biology lesson. This is lesson three um, that I'd like to share with you real fast. I'm going to go through it here, share some of the slides, and I hope you're well. So, lesson three. An acid is any compound that when you stick it in the water, it's going to shed H plus ions. Now, H plus ions are interesting because, as you already know, hydrogen has a proton, which means it has one electron. So basically, anything that's H plus is something that is simply a proton running around the world. Okay. Now, this formula here is the formula that shows us what this chemical reaction kind of looks like. So when you put hydrochloric acid inside of water, it breaks down into its component parts, which are H plus ions and Cl. Now, these things are what we consider it to be an acid. Bases, on the other side, it releases hydroxide into the solution. Hydroxide is a polyatomic ion. What a polyatomic ion is something like the hydrogen by itself has a charge and it acts like itself, but a polyatomic ion is two things and they act like they're a single like element. So hydroxide acts like it's a single element, but it's not really, but we use it in chemistry ways to understand that's what it does. Okay, so it has a negative charge. And when you stick something that in water releases hydroxide ions that are negatively charged, you are making a base. The pH scale. So in 1909, a Danish chemist, Soren Sorensen, invented this pH scale for measuring acidity. Now, what's important about that? It's important that you know that this scale was created to actually count the amount of hydrogen atoms or hydroxide atoms in solution. Okay, that's the reason for the small p. Now, the scale goes from 0 to 14, as you can see in this particular slide, but it's kind of strange because the middle of the road is 7. So everything in the middle on the pH scale is going to be something that is neutral. Okay, like basically water. We try to make the tears and blood, they try to be around there. But as you count downwards from 7, you become a stronger and stronger acid. As you count upwards to 14, you become a stronger base. These pictures are significant because you can see just because you have an acidic solution, you still are going to have some hydroxide ions there. Here, you can see that there's more hydroxide than there are hydrogen ions. So we call that a base. If it's neutral, it has the same amount of each. The pH scale ranges from 0 to 14. Substances with a pH between 0 and less than 7 are called acids. Substances with a pH greater than 7 up to 14 are called bases. The higher the pH, the stronger the base. Right in the middle is everything that is neutral. Neutral is 7, okay, like pure water. I'm add this to word map because there's things that I want you to know. Like for instance, this particular one. Hold on. This particular one, our blood ranges somewhere between 6.5 and 7.5 pH. Okay, this is what your body is trying to maintain this homeostasis with. Okay, not quite acidic, not quite basic. So that's why this is really, really important because that is what your body is trying to do is maintain that balance. And your body is also good at pushing these buffers or things that can neutralize or at least equal out these sharp reactions, these buffers. And buffers are crazy important for us to have and be able to use. This particular picture is similar to the picture that was on the other side. And the important part about this picture is as you have yet a acid or a base, you have more hydrogen ions in an acid or you have more hydroxide in a base. The other piece that I need to let you know about your body and how your body kind of senses this is the taste, your taste buds. When it tastes really sour, you have like, ooh, a reaction to really sour. When it's really, really bitter, you have a reaction really bitter. That is your body letting you know that, hey, this might be really acidic or really basic. Lesson 4 is coming up.